Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 5, Sections 1 and 2, Graphing and Analyzing Exponential Functions Notes. Now, I want you to evaluate each power, so grab your calculator and tell me what 5 cubed is. Well, you should be getting 125. Now, 2 to the minus 3 is a little bit more of a challenge. So as you're doing this, I want you to remember that's 1 over 2 cubed, or 1 over 8, which I believe is 0.125. Okay? And once again, if I'm going too fast, pause the recording. Now, 4 to the 0, grab Mr. Calculator, 4 to the 0 is 1. Anything to the 0 power is 1. What about 0 to the 0 power? Anyway, you guys can figure that one out. Now, the last one is a little bit tricky. 1/4 to the minus 2. Now, you can probably think about that as 1 over 1/4 squared. That's 1 over 1/16. That's 1 divided by 1/16, which is 1 times 16 over 1. The reciprocal is 16. I think. I hope. I wish I pray. Now, moving on. Complete the table of values for the function y equals 2 to the x. And then we're going to graph them. So, y equals 2 to the x, 2 to the minus 3, or 1/8. 2 to the minus 2 is 1/4. 2 to the minus 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. See the pattern forming? 1/8, 1/4, 1/2. Yes. So if we're going to graph these, go straight up the middle as I can. And I want to point out we don't have to make 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, 0, 1, 2, 3. It's probably easier to go like that. Now, plotting these points, 1/8 is like, alright, so that's a half, 1/4, 1/8 is like that. 1/4 is halfway. 1/2 is there. 1, 2, 4, 8. And there we go. Now, I want to point out a couple of things here. This is y equals 2 to the x. See? Oh, come on. Stop that. People are watching. There we go. This is increasing. It's going up. Okay. Now, once again, I'll give you a moment to get caught up because I know I'm going kind of fast. And then we're going to go on and answer questions about this graph. State the horizontal asymptote. Well, the horizontal asymptote, as x goes to negative infinity, what happens to this graph? Y goes to 0. So we have a horizontal asymptote at y equals 0. Okay? The y-intercept, that is, when x equals 0, y equals 1. The domain, well, x is all real. I see no vertical asymptotes. I see no holes or discontinuities. State the range. Y is greater than 0. Not greater than or equal to, because we just said we have a horizontal asymptote here. Okay? So far, so good? Now, here it gets a little bit sneaky. Determine y when x is 1.5. So when x equals 1.5, go up here. X equals 1.5 is right here. Actually, I'll make this green. Getting 2.8-ish. Now that's reading off the graph. And I'm going to go 8-ish because that's not nearly acceptable. You have to graph this on a graphing calculator. So grab your graphing calculator. Y equals 2 to the power of x. Table. Now I would go minus 3 to 3. Set at 0 and go to 8. Oops, a 1. So I got the same basic graph as I've got here. And there we go. Now I don't have the grid lines like I did, but whatever. So second table, something between 1 and 2. How do I find out when x is 1.5? Second table set, where do I want to start? 1.5. Then go to my table. When x is 1.5, 2.8284. 2.8284. So I can read it off the graph, or y equals 2 to the 1.5. You plug that into your calculator. Not reading off the graph, you get 2.828427. 427, ... keeps on going. So there's several ways to do it. I would not suggest reading it off our crude graph. Go to a nice graph on your graphing calculator or solve it. Now this particular instance you can solve it. In the next example, determine x when y is 6. So when y is 6, go up here. That is pretty darn close to 2.5. Is it exactly 2.5? I don't think so. Now I will say, out of our graph, ish. Now, that's not good enough. So what we have to do is realize 6 equals 2 to the x. Now, algebraically, we cannot solve that yet. We will. But grab your graphing calculator. y1 equals 2 to the x. y2 equals 6. And what have you got? I don't know. Let's find out. The wrong one? This one, sorry. Not that one, sorry. This one. My apologies. So y2 is 6. Graph. And there we go. Second, calculate, intersect. Not trace, intersect. Now, depending on your graphing calculator, which version of the TI series you have, you have to be fairly close to the intercept point. And usually you have to be able to see the intercept point on the graph. Not always, but usually. Yes, second curve, y equals 6, yes. Yes, keep going, 2.5849. Oh, come on, stop that, people are watching. 2.5849. 625. Now that's a decimal approximation. It keeps on going, but that's pretty dang good. I said 2.5-ish from my crude graph. Mr. Graphing Calculator says 2.58. I'm happy with that. All right? That's what you need to be able to do. And that's actually more review stuff for you. All right? Now, I'm going to pause the video here. I want you to think about it. And then we're going to go on and do the exact same thing for y equals 1/2 to the x. All right? So, pause the recording, think about it. Let's go on and do the next graph.